This video lesson will explain how to solve radical equations. The prerequisite skills that you need are solving linear and quadratic equations, simplifying radicals, squaring a radical expression, and squaring a binomial. A radical equation is an equation that contains one or more radical expressions. We are going to be focused only on square root equations. So our radical equations will contain a square root expression. The squaring property is what will enable us to solve these radical equations. That states that if a is equal to b, then a squared equals b squared. Again, kind of following that philosophy that what we do to one side of an equation we must do to the other side to maintain the balance or equality of the expressions on each side of the equation. The one issue when we square each side of an equation, we may introduce extraneous solutions. Here's a very simplistic example. Let's say I have x equals 2, and I square each side to get x squared equals 2 squared, or x squared equals 4. To solve x squared equals 4, I have to apply the square root property, which gives us x equals plus or minus the square root of 4, which is plus or minus 2. So my original equation, x equals 2, had only one solution. The squared equation has two solutions. So it contains the solutions of the original equation, but maybe more, just very similar to the rational equation. So when we alter that original form, we have to go back and make sure that our solution checks in that original equation. To solve a radical equation, we will isolate the radical to one side, then we raise each side to the power of the index. But because we're doing just square root equations, the power of the index is understood to be 2. Then we solve the resulting equation, which will either be a linear or quadratic equation. And then we have to check for extraneous solutions, which means we have to go back to that original equation and plug in. Here's an example. We want to solve the square root of 2x minus 4 equals 6. The radical is isolated to one side, so we raise each side to the second When we square each side, the square root of 2x minus 4 squared is just 2x minus 4. Squaring 6 gives us 36. Now we have an equivalent equation without radicals. Again, our goal is to get the x isolated to one side, so as I've said before, we have to kind of unwrap what is attached to x. Now we will add 4 to each side to get 2x equals 40. Divide each side by 2, so x is 20. Now we should check. We substitute 20 in for the x in the original equation. We get the square root of 2 times 20 minus 4. We want to see, is that equal to 6? 2 times 20 is 40. 40 minus 4 is 36, and the square root of 36 is 6, so the value 20 is the correct solution. A second example is the square root of x minus 1 plus 3 equals x. We must first isolate to get the square root of x minus 1 equals x minus 3. Very, very important that you don't just square each term. That is not the way you square one side of an equation. So we have to get the radical isolated to one side. Now that that's done, we can square each side. Squaring the square root of x minus 1 gives x minus 1. Squaring x minus 3, if you need to write it as x minus 3 times x minus 3 and multiply that out, do so. We will get x squared minus 6x plus 9. This is a quadratic equation. We need to set one side to 0 by subtracting x and adding 1 to each side. This gives us 0 equals x squared minus 7x plus 10. Now we factor. The factors of x squared are x and x. The factors of 10 are 5 and 2. They are the same sign with them both being negative, so we have x minus 5 times x minus 2. Setting those factors equal to 0 gives us the possible solutions of 5 and 2. We're not done. We have to check. Substituting 5, we get the square root of 5 minus 1 plus 3. Is that equal to 5? The square root of 4 plus 3 is 2 plus 3, which is 5. If we substitute 2 in for x, we get the square root of 2 minus 1 plus 3. Is that equal to 2? This is the square root of 1 plus 3, which is 1 plus 3, which does not equal 2, right? This is 4, which does not equal 2. So the value 2 is an extraneous solution which must be excluded from the solution set. The solution set then is the set containing 5.